Great. Thanks for all of you to make it to the fifth day of the conference. I know it can be a little conferenced out, so appreciate you coming this morning. So I've entitled my talk, "The Security Challenges in the Eye of the Hurricane, Navigating a Perfect Networking Storm of Virtualization, Mobility, and the Internet of Things." You know, I was thinking a few weeks ago about what metaphor to try and use to describe what's going on in our industry today. And I mean, I've been doing this stuff for a little while, and I've seen multiple different generations of technology, moving from frame to ATM to IP Ethernet with technologies like MPLS, VPNs, and so on. With all of the changes in technologies, I mean, while they're different, they each had their own idiosyncrasies and acronyms and everything, but really the deployment paradigm for all of these new technologies has been the same for the past 15 or 20 years. I mean, you get a new box, you install the new box in the POP, and you have trials and deployments and life cycle. But the paradigm, the operational paradigm was the same. The back office, business support systems and OSS, operational support systems, these things didn't change at all. And what we're looking now with NFV and SDN is really a fundamental change in the paradigm. And what I was thinking was that when you look at the security challenges that are posed by NFV and SDN, you cannot look at these in isolation from some of the other trends going on in our industry today. So things like movements to big data and analytics, Internet of Things, and so today what I wanted to do, let me just see was I wanted to start off the talk talking about why virtualization now. Virtualization is something that's been talked about for a number of years. In the first keynote of this conference, one fellow asked Ibrahim from TELUS, in the academic community, people have talked about virtualization for many years. Why this moment in time? So I think that's worth exploring. I want to talk about some of the other industry trends and changes in security that we are seeing over the past few years, and then finally talk specifically about the challenges of virtualization. So in attempting to answer the question of why virtualization now, I think it's useful to consider some of the history of compute and networking. So, I mean, you can debate, what circles should be up here, but if you look at compute, at the early part of the 20th century, we had a lot of special purpose machines, things like cryptologic bombs, created by various governments, UK, US governments, to crack the Enigma machine. I think there's a popular movie on this. I can't remember the name, but I hear it's pretty good. I'd like to see it. And then we moved over into mainframe, right? So this would have been epitomized by systems like the IBM System 360. And then, of course, we moved into sort of the PC, client-server, web era. And finally, we're into virtualization and cloud. And if you look at networking, and we move from the telegraph to the telephone, and then what I would call data on big iron. So, I mean, we've had a whole bunch of different generations, an alphabet soup of different data technologies. Every time we needed something with a bit more bandwidth, we moved to a new generation of technology. I mean, we've had SONET and SDH and Frame and ATM and X25 and ISDN, and I mean, it's an alphabet soup. And really, finally, we've gotten to the point where we're standardizing now on IP and Ethernet as kind of the penultimate technology. If you want higher bandwidth, you just go to a higher bandwidth rate of Ethernet, right, from gigabit to 10 gigabit and so on. And now, of course, we're seeing, I mean, we're not there yet, but we're starting on the journey to virtualizing the network as well. So I'm not going to talk very much about this. I'm going to assume most of you are familiar with what network functionalization, network function virtualization is, but I mean, really this is just about moving from special purpose appliance mainframe type models of network equipment to low cost commercial off the shelf server, storage, and transport in the form of Ethernet. So I think the question about why service virtualization now, I like this slide because, this really describes the fear of, the telecommunications service provider, and I call this the service provider dystopia. So, 10 years ago, any road warrior with one of these could easily have a monthly cell phone bill of $500, $600, $700. And today, I have, for about $80 a month, I have unlimited long distance in Canada. When I travel to the US, it's $5 a day. I have a whole whack of data, and it's pretty hard. I mean, I have to work hard to go over my, standard monthly rate of $80. So, I mean, there's still road warriors probably who can manage to generate hundreds of dollars in cell phone bills, but those are the exceptions and not the rules. So, for service providers, the revenues are flat. Traffic growth, of course, is exponential. It's only going to get worse as everything, every toaster and traffic sensor and everything gets online. So really, one of the big drivers for this from a service provider perspective, and I think most of you are probably familiar with the fact that, it is service providers who are pushing for network function virtualization. This is not an initiative of the incumbents, right? The, Cisco's, Alcatel-Lucent's, and Junipers of the world are not pushing this agenda. This is a matter of, survivability for the telecom firms. The second is, what Intel calls silicon and software advancements, right? We've seen a lot of trials now where we're getting line rate with linear scalability, against standard x86 platforms, so 80 gigabit per second line rate type traffic, and there's been a lot of changes both in hardware and software development kits to enable this. There's still areas where ASICs, specialized ASICs, are superior. So once you start putting a lot of features, right? So things like encryption and route filtering and packet filtering, multicast, all of this kind of stuff. It's true that at this point in time you can still bring an x86 server to its knees, but this horse race is something that is going to continue probably for many years, and eventually that's going to, over time, that's going to shift more and more in favor of what the general x86 servers can do. And we'll see, I think, that the ASICs get pushed more and more to more specialized functions, right? So the ASICs and appliance-based machines are probably going to dominate in the internet core for some time. And it makes sense that you want to start probably on the edge of the network with CPE and things of this sort. You're not going to want to bet your business on new technology. So, we've gone to the point where we've done the POCs. Now we're getting into early deployment. And of course, once we get operational expertise and work out some of the bugs, we'll be able to move closer and closer to the core. I don't know if anyone would predict when a NFV SDN type solution would replace our internet backbones. That's probably a little bit of time off. I think whether we get there or not really doesn't matter. In the sense that there's a pretty large footprint and a large role to play for NFV and SDN type technologies in a large part of different parts of our network. I mentioned the plethora of internet technologies before. So, throughout my networking career, one of the challenges, for telecommunications firms has been managing the variety of technology. So, for example, a number of years back, we had, I don't know how many of you in the room remember the RFC 2547 biz, RFC 4364 VPNs. These were the layer 3 MPLS BGP VPNs. And one of the advantages of this technology was that you could create a layer 3 VPN connecting all of the corporate sites over any arbitrary access technology. So you might have some corporate sites that were connected with Ethernet, others with Frame, others with ATM, others and so forth. So this VPN technology was kind of a VPN, a glue, that was access agnostic. But one of the challenges of this technology was very complicated. It really wetted the full complexity of the enterprise feature set. OSPF and BGP and route filtering and layer 3 QoS and layer 2 QoS. It was very difficult for service providers to cookie cutter this type of service. Everything ended up being, there was a lot of special bids, a lot of individual case basis type of configuration. So it's really hard to productize and have just a vanilla-based service offering that is sort of low touch, high profitable. Now, of course, we have a lot of convergence between IP and Ethernet, and a lot of the good work by forums such as the Metro Ethernet Forum, I think have created a situation where we actually can have a standardized, low-cost offering with Ethernet everywhere. And because Ethernet is everywhere now, it makes it possible to offer, a standardized, low commodity server based or commodity switch based offering. I think if it was not for what's been done in the data center, I don't know if the service providers would have had the faith to take the plunge that we've seen over the past few years. Some of the other presentation this week mentioned some of these metrics. I mean, if you go and look at the ratio of system admins to network elements and servers with a company like Facebook compared to a typical service provider, a company like Facebook will have one admin for tens of thousands of servers, and a typical telecommunications firm will have, and this is probably really a best case, an admin, for 100 servers. So, I mean, that's several of magnitudes difference. Some other folks, I think, mentioned this week the deployment timeframes for new services at a service provider are years, right? 12 to 24 months. There are so many things that need to be put in place for a new service to be offered. There's the budgeting, there's the planning, there's the network architectures, playing in the lab, trying to get everything work, and then trying to put into place all of the changes in the back office tools, the business support systems and operational support systems, so that you can have automated fulfillment chains, right? There's a huge number of back office systems from order management like Salesforce, inventory systems such as Netcracker and Kramer and Granite and so forth. And one of my favorite examples from Netflix is when they were expanding into Latin America. I think it was 2011, 2012 type of time frame. They rented a whole bunch of capacity from Amazon Web Services in Sao Paulo. And they realized quickly that a lot of the traffic for the Sao Paulo data center was being routed through Miami. And the reason for this is Miami is a hub, internet hub for Latin America. So after they got some traffic statistics, they decided to decommission the Sao Paulo center, and they started to leverage their US East Coast servers. So they just moved from Sao Paulo back to the US with Amazon Web Services. And because they were renting and not buying, this was a relatively easy thing for them to do. A telecommunications service provider, if they were to put into place a new point of presence, I mean, the cycles for, budgeting, all of the purchasing, the big iron, the power, I mean, this is just not possible when you're doing everything with physical build. So, I mean, there's been a huge demonstration effect here, and I think all of the work by, leaders like the Netflix and Google and Apple have really just sparked the imagination of us in the networking community to see what's possible. And I mean, there are some differences between the challenges that a data center poses and what a network requires, and obviously a lot of those details are still being worked out, but I think there's a lot of similarities as well. I like this. This is a slide from that Cisco produced, and you could argue that as a incumbent hardware vendor who's actually has a lot to lose with the new paradigm, you do have to take it with a bit of a grain of salt, but I actually like and agree with the messaging that I've seen here. So in the lower left hand, this graph has two axes, as you can see. The vertical axis are the CPU requirements, and the horizontal axis is throughput. And basically, they're arguing here that the virtualization sweet spots are things for like CPE, low CPU demand, relatively low bandwidth. And in the upper right-hand corner is where you have the ASIC sweet spot, high CPU demands and utilization and high bandwidth. And I think from a security perspective as well, we want to walk before we're going to run, right? Before we tackle something as important as the internet core, we're going to want to start with something with CPE, do all of the lessons learned, figure out the operational best practices, the tweaks we need in software, deal with the software bugs, and then we can move up the value chain. So with that, I want to move over to talking about some of the technology and security trends that we have right now. So I wanted to start talking about the perimeter model of security, rise in the machines, single sign-on and access management, and math and big data. So the perimeter security model is something that served us well for many decades. But with the advent of with partners and vendor access and software as a service, things like Salesforce.com, unfortunately the firewall has started to look a little like this, right? And you look at some of the high-profile hacks, such as Belgacom last year. There were folks going in and changing firewall rules. When you have a firewall with hundreds and hundreds of rules, it's pretty hard to find a needle in a haystack, right? Which is someone accessing a server on a port that's not authorized. And with the some of you may have seen the sticky note before. This is one of the things that came out with Snowden. And so, over on the left-hand side, you can see here that between the user and, kind of the perimeter node, you have a secure socket layer, so everything is encrypted. But once you're inside the Google data center, everything is in plain text. So if you can punch through that perimeter, you can capture all of that user traffic. And so really, what is needed is a shift to a new paradigm. The perimeter cannot be around at the perimeter of your data cloud. Your perimeter needs to be at an individual thing. And I think, if we look at another area, the history of warfare and warfare, and the story of the castle, I think, is instructive. So, for 500 years in medieval Europe, the castle was the sort of penultimate security perimeter defense mechanism. And if you have an army of people with cavalry and swords, spears, lances, and bows and arrows, a castle works pretty good, right? But what happened, right? We all know the story of what happened. So, with the use of gunpowder and the rise of the cannon, the castle as a security perimeter defense mechanism became obsolete. And it became obsolete very quickly. And what we saw was a movement to mobile security defense, which you could say culminated with the creation of a tank, right, in World War I. So, we had moving the protections from the perimeter of your community to creating armor around an individual thing. And this is actually what a lot of folks in the industry are advocating today. So moving to a zero trust model, if any of you are familiar with the work that AT&T is doing with Astra today, they've coined the phrase rings around things. So we need to move to a model where perimeter defense is at the edge of your network, to a zero trust model where the perimeter defense is around each entity you want to protect, whether that's the network function virtualization instance itself, the hypervisor, or an individual physical server. The second trend I wanted to talk about here is rise of the machines, and really there's kind of a dual meaning here. The first, and some folks have already talked about this in some of the other talks, is the rise of the Internet of Things. So we're going to have a lot more connected devices, right? But there's a dual meaning here. So operational support systems is a reference to all of the back office systems in a telecommunications provider that are used to run the network, help automate things. So this includes kind of everything across the full FCAP spectrum, so there's fulfillment and service assurance and all of these different functions. But in OSS stands for operating support systems. The idea is that these are systems meant to help automate things done by a human being. But really, we need to get rid of that middle S to move from operating support systems to operating systems. So a lot of what we're going to see over the coming years is a decline in user-to-machine communication, where individual operators, whether this has to do with an individual operator opening a terminal emulator and doing a secure shell into an individual server or a Cisco router or something of this sort, and doing config troubleshooting or configuration change, or even to an operator logging into something like a Salesforce.com order management tool and configuring an individual customer service that then flows down the whole stack, right, going through inventory and activation and provisioning, all of this stuff. So we're going to move to a situation where a lot of additional network devices will be spawned up automatically, right, in a closed loop process, whether this is in response to a denial of service attack, right, I mean this is an example that's talked about a lot, or whether this is something like bandwidth on demand. Bandwidth on demand has been talked about since I started in this industry, but it really isn't something that's ever taken off. But if you have real-time policy that can detect additional pressures on your network, you can spin up additional virtual machines and additional network functions in response to real-time demand. So there's a lot of new interesting use cases here. The third trend is really around data breaches and insider threat, giving rise to a cottage industry around single sign-on and access management. If anything, really you could make the argument that in the last 5 years it seems like the hackers are winning. There's been a lot of high-profile data breaches, and this has created a situation where security is not just the responsibility of your chief security officer, but this is something that has a presence in the boardroom. I mean, when a security breach leads to has an impact in the hundreds of millions, which is a combination of lost sales, direct cleanup costs, and reduced market capitalization. This is something that directors of companies are, it's keeping them up at night. And I'm sure you all recognize these faces with, the founder of WikiLeaks and Edward Snowden. There's a lot more focus on, network permissions and access today in a way that we've never seen before. If you look at the Verizon Data Breach Investigations Report, which is a very good industry report, they've been doing this for a little while now. These are just a couple of snapshots from the last couple of years, both the 2014 and the 2015 report. It's a little hard to see, I guess, the lower chart here, but you can see starting from 2004 going to 2013, there's a lot more focus on using stolen credentials to break into networks. And over here on the right, you can see pretty consistent over time. Over the last 4 or 5 years, credentials have been used for a lot of break-ins in networks. We've seen a lot of bit rise in RAM scraping here, which is being able to steal information from things like point-of-sale devices. Spyware keylogging has decreased. Phishing, right, being able to steal, whether this is done through software or getting people to reveal information such as credentials and identity, has increased. So single sign-on and access management, some of the drivers behind this are regulatory. So in the financial services industry, there's something called the Payment Card Industry Data Security Standard. So anyone who is storing credit cards and has credit card information flowing over their infrastructure has to comply with the PCI DSS. And if there's, I think, about 12 different areas where they will evaluate your operation. And if you're not compliant, you will actually be subject to a fine. So the industry is pretty serious about this, and so that's driven a lot of operators to adopt a variety of different security tools, including things like single sign-on and access management. We also have different different countries putting into place sets of regulations. So for example, in India, the Department of Telecommunications has put in an act that requires the telecom service providers to allow things like law enforcement agency live mirroring. So, if there's a court order, someone from law enforcement agency can actually request to have, to be able to see what's going on in the network in real time. Some of the other drivers for these technologies are vendor access. So telecom service providers wanting to have tighter controls over what the hardware vendors are doing in their networks to help, address whether it's performance issues or outages and so forth. Securing legacy devices. In telecom networks, it's very easy to turn things off. It's very easy to turn things on, very hard to turn things off. So we have equipment in the networks that are 10, 20, and 30 years old. And a lot of this legacy equipment will have kind of a hard-coded root or admin account that ends up having a credential which is shared amongst an arbitrary number of employees in the company, making it very hard to trace back who did what in case of malfeasance. Insider threat. So again, this is the possibility of, say, an employee going rogue after they've been given notice. And privileged access management. So this is really, just about being able to take all of those privileged credentials and follow best practices, rotating the passwords, hiding the passwords, etc. And then, of course, having all of the audits and analytics that you would wrap around this type of solution. And basically, the way this type of software works is to separate user credentials and network credentials and putting a proxy in between them. So a user would log into a single sign-on system, and then you would log them onto the network on their behalf with a credential that's not known to them. So they actually would never see the username and password used to log into the network itself. And you can actually capture everything they do in a log. So in the case of a command line session like SSH or Telnet, you would capture every command the user executes and every response that comes back from the device. And in the case where people are logging into EMS OSS systems, things like maybe ALU 5620 SAM, which is, has a nice GUI, you can capture a video log of that. And you can further break those things down into events, and you can index all of this stuff and do searches and analytics. So from an audit perspective, you have full audit capability. You can find out who did what and when. And you can also implement best practices in terms of password rotation policy. So every 30, 60 days, 30, 60, or 90 days, automatically rotating all of the passwords for all of these devices in your network. So, the thing about security is, number one, you have to be able to put it into place so that it gets out of people's way. If you make people's jobs harder, people are pretty smart, people are pretty creative, and they're also lazy, right? So if you can't put into place something that people actually see as a value add to their job that makes it easier, they often are going to find creative ways to get around whatever security policies and infrastructure you put into place. The password is a good example of that. Strong passwords are great in theory, but as human beings, we're not very good at remembering them. So, of course, everyone knows this story, right? Everyone likes to use short passwords. People like to use the same password amongst multiple devices. And if you force people to use a strong password, what are they going to do? The sticky note, right? You got a sticky note on your monitor. Multiple sticky notes all over your monitor, right? So, other things would be, there's the concept of four eyes, right? That's not an eye in terms of the letter, that's eyes in terms of what's on our face. So, kind of the nuclear missile silo type of paradigm where if any action done by one human being has to be approved by a second human being, before it can be enacted. Now, if this is preventing people from, doing their jobs and slowing them down, what are the administrators going to do? Well, they can share their passwords with each other, right? So it's important in whatever we put into place from a security infrastructure perspective. It doesn't just have to sound good in theory, it has to be done in a way that people aren't going to be creative and circumvent those things. I guess the other big trend we've seen is around math and big data. So the last few years, we've seen an explosion in all of these tools. There's the Splunks of the world and Cassandra and Kibana and Hadoop and all of these different acronyms and technologies to help visualize data. And a lot of what we've done in the industry from a security perspective has been reactive. And I think something like antivirus is a very good example of that, where you get regular updates with the antivirus signatures, but they're only good at finding last week's virus. They're not so good at finding this week's virus. And of course, the hackers are very creative, so you can take the same piece of malicious code and you can tweak it, right? And now that requires a new signature, right? So one virus can have thousands and thousands of different iterations. So this is really playing whack-a-mole, right? And it's hard to win at whack-a-mole, right? If anyone who's played that game at the carnival. And if you look at, and this is just a random selection of companies here. There's one company that I think is kind of interesting is Silence, and their approach for antivirus is actually not using signatures at all, but is looking at analyzing the factors of a program. So they claim to be able to look at hundreds or thousands of different factors and attributes of executable code, and based on the patterns that they find, they'll be able to identify, what's infected with a virus and what's not. So, I think those sorts of avenues are very promising, where we want to rely more and more on math and analytics to get actionable intelligence to proactively identify stuff as opposed to react, which is what we've been doing a lot of. And if you take something like the identity and access management example, this is here a profile of a typical large telecommunications service provider. So in a large telco, you can have hundreds of thousands of network elements. In the mobile network alone, you might have 50 to 100,000 Bs. You'll have thousands of users, and you would have, for all of the command line sessions, you might have 100 million command line sessions annually, and that would generate about 50 terabytes of data. And for video logs, you'd have about 10 million video log hours captured, which is about 800 terabytes of data. So this is out of, just for a single telco, we can have a petabyte of data for you to do reports and analytics on. And you know, with this, I mean, we've only started to explore this, but some of the analytics you can do are analyzing things like patterns around who logged into the network, what did they log into, when did they log in. So you can find anomalous patterns here in session analytics. Maybe there's a particular user account or a particular set of devices that's only ever used from 9 to 5, Monday to Friday. All of a sudden there's activity on that account or those devices at 4 in the morning. Where are those logins coming from? What protocols are used? What type of how much data is being transferred over that wire? So with all of this information that we can gather, we can do pretty sophisticated analytics to try and identify you know, rogue processes and rogue behaviors. And today, the interactions with the networks are primarily user to machine, but with NFV and SDN environments, a lot of this is going to be machine to machine. So there's no human beings involved in a lot of this activity, and it's going to be important to find that needle in the haystack. We're going to need fairly sophisticated analytics to be able to detect, you know, that there was a rogue, rogue NFV instance or a rogue process in your network. So I want to talk now, shift and talk about the specific threats with network virtualization. So you've probably seen diagrams like this before, where over on the left we have generic network threats, so things like distributed denial of service attacks. Over on the right, there's generic virtualization threats, so maybe a vulnerability in a hypervisor. The center, kind of eye-shaped purple area would be threats unique to network virtualization, perhaps a network function virtualization vulnerability or bug. And then the little round donut hole in the center there are areas where NFV can actually mitigate threats. And the most common example given, of course, is thwarting a denial of service attack by spinning up additional capacity in response to that event. So some of the, now I'm going to ask, does anyone recognize this picture? Not too many. Okay, this is from an old video game. I guess it would have been in the 1980s, called Pitfall, which is pretty simple. I mean, you basically just ran from the left of the screen to the right of the screen and jumped over various obstacles. So this one you can see there's a bunch of alligators. And I think if you were really good, you could hop on each alligator's head. But if you were less adventurous, I think you could jump up and swing over the pit with a what am I looking for? With a vine. So with network virtualization, you know, there are a number of different threats. So number one, there's a lot of attack surface that we're introducing into the network, right? So we have the hypervisor, we have the MANO layer, so management and orchestration layer. So with SDN and NFV, you're centralizing security in a couple of different higher level systems that really have the keys to the kingdom. And we have to put a lot of time and energy and thought about making sure these are protected. In the old world, if you were to compromise an individual router, you compromise that router. If you can compromise the management infrastructure for this virtualized network, you can take down an arbitrary number of devices and services. The other big concern is immature software. So we're going to be creating a lot of new software over the next decade to manage all of this stuff. And anyone who's been in this industry for a while knows what happens with new software. I mean, if you go and look at Windows Server or Microsoft Exchange or the early days of Cisco iOS, it was not that difficult for a good programmer to find a vulnerability. after you have a system like that that's been out in the marketplace for 10 or 15 or 20 years, it's not so hard to find a vulnerability. You have to be a lot more clever, right? With the new virtualization software, I mean, this is going to be a learning experience for all of us. There's going to be bugs, right? We're going to have to react to them. We're going to have to fix them. But it does suggest we need a little bit of caution. It also creates a lot of the resource sharing and multi-tenant arrangements. So there's going to be a lot of different business models where you have different sort of landlord-tenant type relationships, and there introduces a lot of opportunity for things like you know, east-west type attacks, right? So vulnerabilities in you know, as a result of the hypervisor, where one virtual machine and VNF can actually find out information about what's going on in a you know, another VNF instance, for example. Of course, and there's challenges around industry regulation. So each vertical has its own set of regulation, whether it's finance or medical. You know, a lot of these have rules around the geographic location of information and all of this sort of stuff. And we'll have to tackle those things in the coming years. This is just a picture of the architecture. So I mean, I think I'm not going to go through all of this, but you know, it just gives you a sense as to, you know, all of the different areas we need to secure. So, you know, over on the right-hand side of the screen, we have the management and orchestration layer. So we have orchestrators and VNF managers and all of this sort of stuff. So I thought this was a quote I liked from a recent publication from SDX Central, right? The promise is, you know, a single common server architecture that can be used to build redundancy and availability organizations require within their data center environment. You know, and shared virtualization infrastructure can simply move workloads to ensure ongoing capacity and performance. So, you know, I guess the dangers here are, you know, this whole set of infrastructure could end up looking like that perimeter-based security model, at least in the short term, if we're not careful. So, you know, number one, of course, we have all of those new attack surfaces, and, you know, I think of the hypervisor compared to big iron, such as a large, you know, router or switch. If you take down that that router switch, you've taken down one thing. If you take down a hypervisor, you can take down every VNF on that hypervisor. I guess another area of concern is the fact that this stuff's become cheap and ubiquitous. So, you know, you take something like the equipment that you find in a point of presence at a communication service provider. Some of this equipment's pretty hard to get your hands on. It's specialized, it's expensive. You know, the list prices of just the line card modules on some of these boxes run in the hundreds of thousands of dollars. So it's not something you're going to find in someone's basement. But with x86 machines and you know, Ethernet NICs, these are things that anyone can get their hands on and play around with. I guess the other issue here is there being a handful of vendors. So, you know, with x86, we have AMD and we have Intel for the processors, and for the Ethernet modules, you know, there's look at controllers and stuff. I mean, there's Marvell and Intel and various players like this. So, you know, a vulnerability in one area means a vulnerability across our entire infrastructure. And if you think of this, I think this is actually a magnification of vulnerability. So you look at what happened with Heartbleed and Shell Shock. I mean, some of you probably remember the panic that ensued right across the entire industry, knowing that you know, Bash was vulnerable. So if we have an entire network based on NFV technologies, you know, with a standard shell, and we have a vulnerability across that hypervisor, you know, we don't just have a vulnerability in one piece of our network, you know, maybe the eNode B portion of the wireless network, or maybe that Cisco or router, Juniper or Huawei router in the core, you have vulnerabilities across your entire network. The other meaning of magnification here is, of course, a compromise of your hypervisor means a compromise of potentially all of the VNFs on that hypervisor. And a single vulnerability can compromise an arbitrary number of VNFs. So I think this is, again, kind of a note of caution. We're going to want to start small and get operational expertise and harden all of these technologies as we expand, before we expand them. So mitigating the pitfalls. So I think one, as I've said earlier, we need to redefine the perimeter. The perimeter is not the edge of your POP or your data center. The perimeter is the thing itself. So that's the individual VNF. It's the individual hypervisor. It's the individual piece of physical equipment. The other thing we can do here is on-demand policy change. So, for example, let's say either a human being or a machine wants to access a particular function, right? We can do punch a hole in a firewall in real time in response to that request. So you take something like a single sign-on and identity management system, a user will log into that system, request access to a device. We can go through an API, punch a hole in the firewall, let the person log into the device, or the machine execute whatever it is that process is going to do. Once that logs out, you can take away that hole in the firewall. So policy can be real time. Security zones is another obvious thing. So for VNF placement, like with like, you're not going to put a back-end user database with a front-end web server type of process. So we're still going to want to practice all of our best practices of having demilitarized zones and different perimeters of security within the network and the data center. We're going to follow those practices as we architect networks and figure out what VNF goes where. Other obvious things, traffic isolation. Of course, you're going to have dedicated management VLANs for your management traffic and all of the communications between your Mano infrastructure and the network itself. Encrypt everything, and this has a dual meaning as well. File systems need to be encrypted, and any communication between any device on that network needs to be encrypted. And of course, with centralized control, I think we can get a bit more visibility into patch levels, things of that sort. Anyone who's involved with managing a large network knows that, you end up getting so many different versions of software and firmware out there, and it can be a bit of a challenge to keep all of that stuff current and up to date. Things can sometimes tend to age out, especially when you're dealing with stuff like CPE. With centralized management, I think at least in theory, it becomes easier to keep everything up to date. Another area, of course, is software integrity protection. So, this is a whole host of different things, right? Software signing and secure boot and runtime inspection. Again, a lot of these instances will be spun up in real time in response to, various closed loop events and business logic. So, it's going to be important to ensure that when a new virtual machine or VNF instance appears on the network, that it is a legitimate instance. And that has to be all machine driven, right? Human beings aren't going to be, human beings will still start up individual things when new services are purchased, but a lot of this will be dynamic, right? You take something like the Netflix example again today, where as people come online and start watching movies in the evening, thousands of additional virtual machines are getting spun up. And when people stop watching the movies, those virtual machines are getting spun down. So I expect the network will start looking a lot more like this as well. It won't be the standard life cycle we have today, where you budget for a machine and you purchase it and you deploy that piece of hardware and you do initial configuration and you do service configuration and you do ongoing monitoring, and then after its life cycle it's eventually decommissioned. We'll have a lot of general compute and network capacity in our points of presence that will be spun up on demand. The other key here is access and credential management. So we'll want to have a single sign-on for everything, and this applies to both human-to-machine communication and machine-to-machine communication. So any request that goes from an orchestrator or a VNF manager to a VNF needs to go through a proxy that captures those streams through the APIs so that you can do post-mortem analysis in some cases, for an event by a human being at a later point in time, but more importantly, so you have the raw data available to all of your analytics tools. Analytics and alarming, I guess I've already, the other thing here is not only are the analytics important for finding that needle in the haystack, but you can actually even have, closed loop real-time countermeasures, right? So you can do things such as, based on certain security events, you can go through an API and, change QoS policies, you can change firewall policies, there's all sorts of things you can do. I mean, obviously, you have to be aware of false positives, and you want to be pretty confident that any closed loop action and real-time countermeasure is only going to be enacted when it's actually needed. But I mean, that's a learning process, and we can refine that as we go. Of course, we'll need to have secure APIs for all of the nano infrastructure. And in this world, of course, there's lots of different business models for the ownership models and rental models. So there'll be different landlord-tenant type relationships in this network. And we'll want to make sure we have a fairly strong instance-based security model so people can only access the VNF instances they're entitled to, or hypervisors are entitled to, and so forth. I guess one example here, there's been some talk on over the past year or so, is an example of hypervisor introspection versus virtual machine or virtual network function-based security. And hypervisor introspection is really just about allowing the hypervisor visibility into the hosted VMs and VNFs, right? So basically it means putting more functionality in the hypervisor and having shared security. So for example, you can put firewall capabilities in the hypervisor, right, as opposed to within each VNF. So that's going to save on system resource utilization if each VNF is not spawning all of its own processes. But the problem there, of course, is if your hypervisor is infected and compromised, then every VNF is compromised. And of course, this also means that the hypervisor is going to have a lot more code in it. More code means more bugs, more attack surface. With VM or host-based security, each VNF is responsible, has its own individual ring around it. But of course, this means higher resource consumption. I think we'll see both of these things, and a lot of it will have to do with what business model is put into place. So in the case where this is a private cloud and you're a telco, if you, let's say you own the entire infrastructure, right? You own the NFV physical infrastructure and the management layer and the hypervisor and the VNF, probably makes a lot of sense to have hypervisor introspection in this type of an environment. If you're doing this as a service, so you have VNF as a service type model, and this is a hosted based service, you might want to put into place your own firewall directly on the VNF itself, as opposed to relying on the infrastructure provider. So I guess, what the industry doing right now, I think is the right thing. We've seen POCs, to demonstrate some of the capabilities and really learning how all of this stuff's going to come together. What's the VNF going to do? What's the hypervisor going to do? And what's the management and orchestration layer going to do? And we're moving into the early stage deployments and trials in real networks. Of course, we want to walk before we run, and a colleague of mine sent me this a picture earlier this week, and I thought it was apropos. I mean, there hasn't been a lot of talk about security, because I mean, really, before we can get into real detailed discussions of security, we have to figure out how all this stuff is going to work. The important thing, though, is whatever we do, we don't want to put into place a, you know, a very complex security model that sounds great on paper that people aren't going to use and are going to bypass. So I mean, this is going to be a learning process, and I'm very curious to see, you know, what happens with some of these early deployments over the next few years, and you know, what kind of security vulnerabilities and how we respond to that. But anyway, those are some of my thoughts.